Today we would like to present the Nostradamus tool, a tool that is based on machine learning methodologies and the cumulative research of Exactpro Research and Development Department. Nostradamus allows to resolve tasks for different groups of IT specialists. QA engineers can improve their defect reports using this tool. Software developers can discover hidden dependencies in the development. Project managers can analyze project status. Let's consider each option separately. Nostradamus can improve defect reports by generating recommendations for QA engineer. Junior specialists can use these recommendations in order to make their defect reports better and more understandable. It's possible because the machine learning algorithm is sensitive to the text the submitter is writing. Nostradamus allows to correct the release policy because it's able to predict the testing metrics. Project manager can change the release decision when he or she knows that the defect can be fixed within a certain time period. Knowing that, they can either include the software feature into the next version of software or exclude it from the next version. Architects and developers can tackle software weaknesses and improve the development strategy via defect clustering. It gives a chance to understand the nature of defects, because the number of defects that affect the decision-making process is reduced from 1,000 to just several bug representatives. A highly experienced QA engineer can only assume how defect attributes connect, but it's just intuition that is hard to formalize. In contrast, machine learning algorithm can reproduce these dependencies that are hard to reveal by human processing capabilities alone. Moreover, it can calculate the output for new data. Unlike human intuition, these capabilities, capabilities of learning, is quantifiable. The description of a bug report is one of the crucial things, and it's in text format. So Nostradamus transforms text via natural language processing methodologies and analyzes how the user writes the description. It allows us to evaluate the significance weight of every word and determine the top of the most significant words for every predictable output. Nostradamus learns from defect reports that are submitted into the bug tracking system. The learning process is presented on slide number 10 in the data mining module part. It includes text pre-processing, feature extraction, feature selection, and classifier building. From this model, we get machine learning models. When we get new defect reports that were not in the training data set, we use these built models. So Nostradamus creates recommendations that are based on the calculated models. And finally, the recommendations and the user's estimation are recorded into the database. We record the user's estimation in order to improve the classification models. The complete architecture of Nostradamus is presented on slide number 12. Nostradamus is written in Python. Python has been widely adopted by scientific community because it's productive, powerful, and readable. Moreover, its libraries include powerful statistical and numerical packages. Python's ecosystem keeps growing year after year, and it becomes more and more capable of statistical analysis. Let's move on to the examples. As I mentioned earlier, Nostradamus calculates various probabilities, and the way it displays them is histograms, pie charts, and a curve. Let's imagine that we have a problem with memory consumption and a subsequent crash of each gateways. Then we change the phrase about the crash and add a phrase about the attachment files. The original description is displayed in the before column, and the modified description is presented in the after column. In the original case, high priority has the highest probability. But according to the new description, it's likely that the defect is critical. In the modified case, the probability of a won't-fix resolution has decreased significantly. It happened because we slightly clarified the crash situation and added the information about the logs, dumps, and other files that confirm the submitted problem. So the first example was about adding text. Now let's consider the example when we slightly change the wording. In the new example, we have a problem with inconsistencies between a database column and a corresponding field in the front ends. And we are politely asking the assignee to confirm and clarify these database changes. Then we slightly change the wording. We're asking not to confirm the database changes, but to update the specification. The probability of the issue belonging to the release area has become lower, because according to the new description, the focus shifts from it being a release problem to more of a system problem. After the changes in wording, we see that the metrics have updated. The probability of a medium priority has increased. Nostradamus recalculates the probability of a time to resolve according to the changes in the description. And you can see these differences on slide number 18. The last example is very interesting too. It's devoted to fixed gateway message problem. Then we just add a couple of words about attached logs and pickup files. After this addition, the issue becomes a lot more likely to belong to the interfaces area, because this information is important when it comes to the gateway area. We expect that Nostradamus will give wide range of IT specialists a possibility to improve their software products. In the near future, we are planning to analyze not only the snapshot data, but the data in the context of dynamic changes. It will let us to discover more complex dependencies via Nostradamus. Thank you.
Yes, so it's good. For now, it's presented like we are taking the issue description from the snapshot, and it is not clear for me now how it will be working if we basically considering the dynamic updates, because I know from the experience that sometimes the issues rise like we see like a top of the iceberg. When you first read it, if you're a product owner, you can consider that it's a low issue, we don't need to fix it. But afterwards, after the analysis from the developers, they say that, oh no, if something other happens, this may cause a major problem. So I think that you consider in this way that the description and the subject should be updated then, or how it should be managed, that Nostradamus should pick up these changes and basically, I don't know. The problem is, I'm saying that the product owner will look to the issue from the beginning, from the original description, and if we are like skipping the product owner and using only Nostradamus, Nostradamus will say, it is a low issue, let's do not consider it, and we've missed the bug, the major bug.
Okay, thank you for the question. Firstly, I would like to say that we gather the estimations, the user estimation, in order to improve. It's first of all. Secondly, we can analyze not only single description, but we can analyze set of descriptions, and it's more useful for product manager, for example. And I think that dynamic changes can be useful in order to define and determine different dependencies that are not that are not obvious when we try to analyze snapshot data. And we think that it's a significant moment. But, and moreover, I can say that about one interesting thing that we can use combination of recommendations, I mean Nostradamus recommendations, and expert evaluations. Only combinations. We don't talk about situation when we try to, when human is replaced by machine. Not only combinations, because Nostradamus creates false positive results, and an expert can select the right results from these data, and this common practice of machine learning.
Anna, could you please say what was the biggest challenge when you was working on Nostradamus, when you was creating Nostradamus? What was the biggest challenge for this machine learning task?
For me, the biggest challenge is the pre-processing data, when we need to understand what kind of attributes we should analyze, how we can pre-process them, how we can normalize, standardize, and other. Moreover, we have some problems of imbalanced data, and we need to resolve this problem too. I think that pre-processing is a key moment when we say about machine learning, because if we work with bad data, we get bad results.
One more question. I'm here. Do you plan develop a personal assistant, like virtual assistant? Name already good.
Like Siri.
Nostradamus. I mean, at least chatbot. Okay. Do you think this bug is okay? You know, it looks like critical. Let's study it together.
Just please don't submit defect.
Yeah. So, do you plan to have to develop to upgrade it in this way?
I can say that we have a lot of interesting things that I think could be developed when we say about Nostradamus. And moreover, okay, why not?